Hey everyone, this is the study guide for the quiz or test coming up on Friday for Algebra 1 in Mr. Hickson's class. So if you're watching from my class or another class, welcome. Alright, so number 1 says that at 3 p.m. Jacob hops in his car and drives at a constant speed for 5 minutes to the post office. After 4 minutes at the post office, he realizes he is late and drives faster constant speed to the grocery store, and then it keeps on telling the story. It says that we need to draw a graph that shows the distance of Jacob's car from his house with respect to time. Remember to label your axes with the units you chose and any important points. And in parentheses it says home, post office, grocery store. So we'll start off with a graph. And it says that we need to have distance over time, or distance with respect to time. Let me redraw this a little larger. So on the side here, we're going to have distance. And since he's driving, we'll just call this miles. Although in this particular one, it doesn't give us a unit for distance. And then for time, looks like this all happens between 3 and 3:25. So we'll call this time in minutes. And then we need to label our axes a little bit more. So again, it doesn't give us an exact distance, so it's going to be hard to label the y portion of this, but we can definitely label the x. Alright, that should be enough. So I'm just going to go by 2's. And it says at 3 p.m., Jacob hops in his car. So he's at home. So if Jacob's at home, then his distance from home would be 0. So he's going to start there right at 3 p.m. He's going to drive a constant speed for 5 minutes to the post office. So for 5 minutes, 1, 2, 3, 4, 5, he's going to drive a constant speed, and we'll say that the post office is right here. And I'll try to draw a straight line, and we'll call this the post office. After 4 minutes at the post office, so he spends 4 minutes at the post office. Oh, and I messed this up already, so I said I was going by 2's. Sorry about that. So let me just back this up a little bit. So if it took him 5 minutes to get there, and we're going by 2's, that means he arrived at this point. And again, we'll call this the post office. And he sat at the post office for 4 minutes. So we'll just go up, and this should be at 9 minutes, right? If this is 10. And he didn't move at all from there. He didn't change his distance. He was at the post office the whole time. So we'll just have a straight line. So after he spent the 4 minutes at the post office, Jacob realizes he's late and drives at a faster constant speed to the grocery store, arriving at 3:25 p.m. Well, so we go on our x-axis. We need to find 25. So if this is 10, 12, 14, 16, 20, 22, 24, 25 would be right here. So at this point, he's going to arrive at the grocery store. And again, we don't have an exact distance, but we know that it was a steeper, it's going to be a steeper line than before because he's driving much faster. And then I'll do my best to connect these, but this is probably going to be awful. Alright. And that's when he arrived at the grocery store. Once we got to the grocery store at 3:25, he spent the next 20 minutes buying groceries. So from here, from our 25-minute marker, he spent 20 more minutes. So we're just going to count up by 2. So here would be 2 minutes, 4, 6, 8, 10, 12, 14, 16, 18, 20. So then we'll find that point up here. And again, remember his distance is not changing from his house. He's still at the grocery store the entire time, so we'll have a straight line here. It doesn't say anything about his return journey. It just says that he spent 20 minutes buying groceries, and that's the end of it. So that's where our graph will end. Alrighty. Go ahead and jump to the next problem, and I'm going to erase this so that we can work on it. Alright. Numbers 2 through 5, we're tasked with simplifying the expressions completely. So number 2 says 4 parentheses 3 minus 4x plus 6. So the first thing we're going to want to do here, normally we would want to do what's inside the parentheses, but because we have a 3 and a negative 4x here, we can't actually do anything there. So what we're going to do is to distribute this 4. So we'll do 4 times 3, and then we'll do 4 times negative 4x, excuse me. So 4 times 3 is going to give me 12. And 4 times negative 4x is negative 16x. I'll go ahead and bring down the rest of my equation, which is that plus 6. Now you'll notice at this point I've got like terms. Right, we have the number 12 here. Remember that that negative is attached to that 16x, not to the 12. And we have a positive 6. So we have two positive numbers, 12 and 6. We can combine those, and you'll get 18. And then we'll bring down what's left in our equation, which is that negative 16x. So if you're in Mr. Hickson's class, I'm okay with this answer, but really you should be moving these around. So you've got negative 16x plus 18. And if you're not in Mr. Hickson's class, I don't know what your teacher is expecting you to do, but this will be our final solution. Alright, number 3. Number 3 says 5 parentheses p plus 12 plus 3 parentheses x plus 11. Alright, so the first thing I'm going to do is distribute this 5. Now you could start by distributing the 3 if you want to, but I'm going to distribute the 5. So 5 times p is just 5p. 5 times 12 is positive 60. And then I'm going to bring down everything else. In my class, we talked a little bit about distributing this both sides right away. And remember that I mentioned that you could do that, but it's best to keep yourself organized by doing just one at a time. So now I'm going to distribute this 3. We need to do 3 times x. And then 3 times 11. 3 times x will give me 3x. And 3 times 11 is positive 33. Now I bring down the rest of this. I've got 5p plus 60. And remember that the 3x is positive, So we'll put that positive sign back there. Now notice I don't have any other terms with p in them, so I'll just bring down the 5p. And I don't have any other terms with x's in them, so I'll bring down the positive 3x. I do, however, have two terms that are just numbers. I have positive 60 and positive 33. So from there we'll just combine those together. 60 plus 33 is positive 93. And that should be your answer for number 3. Alright, number 4. 4 says 12 minus 2x minus 5 minus 3x squared minus 8x plus 10. So here there are no parentheses. We don't have to worry about distributing. We're just looking for like terms. So I'm going to start with the variable with the highest exponent, because that's the order we should be going in. I have a negative 3x squared, and I have no other x squared, so I'll just bring that down. Next up, I have a negative 2x and a negative 8x. Negative 2x minus 8x is negative 10x. After that, I've got a positive 12 and a positive 10 and a negative 5. So we can take this just one piece at a time. Negative 5 plus 10, or 10 minus 5, is going to leave us with 5. And then if we add on that positive 12, you'll get 17. And we'll just bring that over here, positive 17. That should be your answer for number 4. Alright, number 5. Number 5 says 8w cubed, oh, no parentheses here, sorry, minus 5w minus 17, in parentheses, plus 2 parentheses, w plus 6 in parentheses. So again, we'll start by applying the distributive property. We'll do 2 times w, and then 2 times 6. 2 times w is 2w, and 2 times 6 is a positive 12. Also keep in mind that this 2 times w is a positive 2w. And then we can bring down everything else that we didn't really work with here. So we've got parentheses, 8w cubed minus 5w minus 17 in parentheses. And I'll go ahead and shift the rest of this over. Whoops. Plus 2w plus 12. Now, we can apply the associative property. Remember, the associative property says that the order in which we do these things doesn't matter if we're adding. And remember that the inside of these parentheses, this 8w cubed minus 5w minus 17, is really just a series of addition. So we can go ahead and remove the parentheses. And we'll have 8w cubed minus 5w minus 17 plus 2w plus 12. Real quick, if you didn't quite understand what I meant by that, 8w cubed minus 5w minus 17 is the same as saying 8w cubed plus a negative 5w plus a negative 17. And remember that if we have all addition, which we do here and here, the associative property says that the grouping doesn't matter, so we can go ahead and remove those parentheses. Now we're looking for like terms, and I'll start with the largest exponent, which is 8w cubed. There are no other terms that have w cubed, so we'll just leave it. Next up, I've got a negative 5w and a positive 2w. Negative 5 plus 2 is negative 3w. And last but not least, we've got a negative 17 and a positive 12, which will become a negative 5. And that's your answer for number 5. Alright, I'm going to erase all of this stuff, and then we'll go ahead and get started on the next problem. Alright, the next one has a diagram that I'm going to attempt to draw, although my artistic ability is lacking, as you might have noticed. Okay, so here it's asking three questions, excuse me. I went and answered one of them for you already. So it's asking what property is being applied here, and then what we end up with here. So we'll start in the top left corner here. We've got L times parentheses M times C, and then it's becoming parentheses L times M and parentheses times C. So if you notice, the thing that is changing here are the location of these grouping symbols, these parentheses. We're grouping two different things. Here you had MC grouped, there you have LM grouped. So this is applying the associative property of multiplication. Now we'll move down to the bottom right corner. We have, again, ML grouped, and then it's changed to C and M grouped. So we're changing the grouping. So again, we're applying the associative property of multiplication. Now, if we apply the associative property of multiplication here, which is what it's asking us to do, if we apply the associative property, we're just going to change the grouping. So instead of grouping M and L together, we'll group L and C together, which means we'll be left with M times parentheses L times C and parentheses. Alrighty, from there you should jump to the back so we can start the next problem. Right, number 7 gives us kind of a story, and it's asking us in part A to sketch two graphs on the same, or two lines on the same graph, excuse me. And it tells us that it's an elevation in feet versus time in seconds. Now, I believe all classes should be requiring you to label that, but for sure, Mr. Hickson's class, you are required to label your graphs. So then it says Duke starts at the base of the ramp. Alright, so Duke's starting here at the bottom of the ramp. And it says he's increasing his elevation by 2 feet every second. So for each second, let me add on some tick marks here. Alright, so Duke's starting at the bottom and he's increasing his elevation by 2 feet every second. So for each second, he's going to go up 2 feet. So into the next second, he goes up 2 feet. And into the next one, he goes up 2 feet. And my line's not going to look perfect because my graph was not constructed perfectly, but on your paper you should be able to get a perfect idea of what's happening here. So for each tick mark, you're just going to go over 1 and up 2 because he's increasing 2 feet, so going up 2 feet for every 1 second. So again, up 2 feet, right, 1, 2, and then over 1 second. Should look more like that. And eventually you'll be able to construct a line. Oh man, that's awful. Sorry, it's not too easy to draw straight lines on this program. And then we'll look at the next person. It says, Shirley's starting at the top of the ramp, which is 40 feet high. So we know that this has an elevation of 40 feet, and Shirley's starting at the top of this ramp. And her elevation is decreasing 4 feet per second. So for each second, so as we hop over 1, she's going to decrease 1, 2, 3, 4 feet. And then we'll do it again. We'll jump over 1. We'll decrease 4. 1, 2, 3, 4. And then we'll hop over again and decrease 4 more. 1, 2, 3, 4. And again, you'll be able to construct a line that's hopefully straighter and nicer looking than anything I could do. And your graph will look something like that. Notice that, well, mine's not really a line, but if it were, the line in green, the line for Shirley, would be steeper because her rate of change is larger, right? She's decreasing her elevation at 4 feet per second, whereas he's only increasing his at 2. Part B says, what does the point of intersection represent? We talked about this a lot in class. Remember that this is when they're kind of running into each other. And it also it represents that at that specific time, their elevations are equal. So your answer should say something like that. All right, number 8. Number 8 asks you to take, whoops, let's redo that. Number 8 is asking you to take this expression, 4abc minus 7a squared plus 8abc, and find equivalent expressions. So the first thing we want to do is identify like terms. I noticed that both this and this are like terms, right? They all have an A, they all have a B, and they all have a C, and all of them have the same exponent. So we can use the associative property, right, to change, or not the associative, excuse me, the commutative property to change the order of this. So I can bring the 7a squared out to the front, plus 4abc, plus 8abc. Once I've done this, I have my like terms right next to each other. I can go ahead and combine them. So I'll end up with 12abc. And I'll bring down the rest of this. So now if we look at our options, A says 4abc minus 7a squared. But if you notice, they just kind of left off this 8abc. So A is not going to be an option. They kind of just got rid of that 8abc. You can't just get rid of things. You're not Houdini. Alright, now for B it says 12abc minus 7a squared. Now this is similar to what we have, but remember we can apply the commutative property again and move this 12abc over, and we would get 12abc minus 7a squared, which does match what they've given us for B. So B is a possible answer. But remember this says circle all answers, so we've got to check the other ones. So B is definitely an answer. Now let's look at C. C says negative 7a squared plus 12abc. Well, that's what we had the first time right there. So this definitely does work as well. So C will work. And now let's look at D. D says negative 7a squared plus 4abc. And this is similar to letter A that they gave us. And recall that A didn't work because they just kind of forgotten this 8abc. The 8abc is just gone. So that's not an equivalent expression. So your answers should be B and C. All right. For number 9, it asks you to match the different types of graphs. Graph 1 looks like this. Graph 2 looks something like this. And that was graph 2. And graph 3 looked like this. Alright, so we'll start with graph 2. I think that's going to be the most recognizable one. Oops. Oh, my pen's freaking out. Sorry about that. Graph 2. There we go. So our options are exponential, quadratic, and linear. So remember, if you remember nothing else, you should remember that linear means a line. And if you look at all of these, well, none of them are lines because I can't draw straight lines. But if I could, graph 2 would have straight lines, right? Graph 3 is curved. Graph 1 is curved. But graph 2 has, or is supposed to have, straight lines. Right? It's the only one that has straight lines. Remember, it is linear because of the straight lines. And it is piecewise because it's a bunch of lines that continue onward. We talked about this in my class. How this line, for example, is really a line that just keeps going, and we're just borrowing part of it. This next line, this line segment here, is a line that just keeps going, and we're just borrowing part of it. This line segment here, in reality, would keep going, but we're just borrowing part of that line. And then this line segment here is a line that keeps going, but we're just borrowing part of it. So that's what makes this a linear piecewise function. So graph 2 is going to be C. Now if we look at graph 3, recall that a quadratic gives this sort of weird U shape, or upside down U shape. And remember that a quadratic mirrors itself. So what it's doing over here, it must mirror over here. That was the my lines are so bad. That was kind of the idea of a quadratic, right? Is that it looked different from an exponential for a couple of different reasons, but one of the major ones is that it mirrors itself. So because this one mirrors itself, we know that graph 3 is quadratic, which is B. Now if you look at this one, graph A, we talked about how exponentials get steeper and steeper and steeper as they go up. And then as they come down, they end up approaching something. Sometimes it's 0, sometimes it's not. But they never cross it, right? They never go over it. They're just going to kind of keep getting closer and closer and closer, but never actually touching. And that's exactly what it looks like graph 1 is doing. It doesn't ever touch that axis, but it gets awfully close in the end there. So this is definitely an exponential. Alrighty, let's go erase the top here so we can do the last problem of your study guide. Alright, so the last problem gives you some tables. I'll go ahead and write them out, and we'll look at them individually. So A and B. Now I'll go ahead and make the table for C. All right, and as we read this, we want to try to keep in mind what is important because there's a lot of words going on here. Assume a bacteria population doubles in size every hour. All right, so out of that first sentence, the fact that it's bacteria, I mean, it's important. It gives it some context, but if we're just purely looking at the math, that doesn't really matter to us. But what does matter is it's saying the population, or how many we have, is going to double every hour. So every hour, it's going to double. So we want to keep that in mind. Which of the following three tables of data, with X representing the time and Y representing the count in bacteria, could represent the bacteria population with respect to time? There may be more than one correct answer. All right, so we've got some bacteria that are doubling every hour, so we want to look at each of our tables to see which one represents doubling every hour. So for C, we're starting off at a time of 0, which is what you'd expect. You're starting at 0, and you've got 3. So if we're doubling every hour, we would expect that at 1 hour we would double. So we'd go from 3 to 6, right? And then from 6 to 12. And then from 12 to 24. Right? Each hour we would double. But if we look at this table, we're starting with 3, but then at 1 hour they have 12 when we were supposed to have 6. So C is not going to cut it. Now if we go and look at A, we're starting with 5. Cool. All right. So we expect that in an hour it should double to become 10, and in an hour that should double to become 20, and in an hour after that doubling to become 40. So if we look at this table, we have 5, and then instead of doubling and going to 10 like we have here, we go to 15. So that's not going to work. So we know that A is out. So unless the guide was made completely incorrectly, you should at this point be able to figure out which answer is correct. And if you notice here, we're starting at 5. When we double, we should go to 10. And then in an hour, when we double it, we'll be at 20. And then in an hour again, when we double it, we'll be at 40. And if you look, we're starting at 5. We're doubling to 10. We're doubling again to 20. And then we're doubling again to 40. Alrighty, that is the end of your study guide. I hope you enjoyed the video. If you've got any feedback for me, if something wasn't working, or I wasn't loud enough, or whatever your feedback would be, please let me know. You can either just see me in person, or if you're not in my class, feel free to let your teacher know or email me. Anyway, good luck, Algebra 1 students. Study well, and good luck on your test.